Take a moment to think about whether or not you know these laws off by heart. The three laws of motion by Newton. The first law states that an object will remain at rest or travel with a constant velocity if the net force acting on the object is zero. The acceleration of an object is directly proportional to the force applied, and inversely proportional to the mass of the object. And the third law states, if object A exerts a force on object B will exert an equal and opposite force on object A. And you need to know that these forces act on different objects. Now, truth be told, most students do not really understand the three laws of motion. They are actually quite complicated. So, let's start with the first one. No, they are not really complicated, I think, because people usually, to understand the three laws of motion, what they will do is they will draw parallels with other analogies, or they will try and use analogies which are not quite fit for explaining the three laws of motion. They will try and use they will try and draw parallels with scenarios that do not actually fully encompass what the laws of motion are trying to dictate, what they're trying to communicate. So let's start with the first law of motion. An object will remain at rest, travel with a constant velocity if the net force acting on the object is zero. The key word here is net force. So let's start a little bit explaining the very, very basics. I will go on to this again, but let's start with the very basics. In physics, we have two types of measurements. We have scalars and vectors. So let's start with the scalars. The scalars are divided into distance, time, right? These are things that do not have a direction. There are also other units which we call vectors. Vectors, on the other hand, they have a direction. For example, that's a really bad V. Right, vectors, on the other hand, have a direction. Vectors are not distance, they are displacement. It might be velocity or acceleration. So we have scalars, right, such as distance and time, but we also have vectors like displacement, velocity, and acceleration. Usually vectors will have this pointy arrow at the top. The arrow indicates that they are a vector. So let's try and explain it using an analogy. The difference, for example, between distance and displacement. Let's say there is a wall, and there is a frog trying to jump up the wall. The wall is 5 meters tall. When the frog jumps, climbs up the wall, all of a sudden it slips back down. So it moves, and then it tries again, and then it slips back down again. Right, so this happens. And it climbs back up. So frog climbs back up, slips, and climbs back up. The distance that the frog has traveled is 15 meters. The displacement, on the other hand, is equal to 5 meters, because at the end of the day, from the initial position to the final position, the frog has only traveled 5 meters. You might say it has only displaced itself by 5 meters. You might say, well, that isn't fair. The frog has definitely done much more than that. It has traveled 15 meters, right? Well, truthfully, no, right? Truthfully, yes, it has traveled 15 meters, but its displacement is only 5 meters. Now, why is it important to learn about scalars and vectors? In physics, in units 1 and 2, you will learn the fundamentals. But there is a lot more that goes into it. A lot more. You will learn about a lot of formulas. Plenty of them. Some of the basic formulas are V is equal to, technically speaking, let's start with S, which is speed. It's distance over time. Speed is a scalar as well. But another formula is actually V is equal to displacement over time, where V is velocity. Now, velocity is a vector because displacement is a vector. Acceleration, on the other hand, is equal to change in velocity over change in time. And therefore, acceleration also is a vector because velocity is a vector. Now, these are some basic formulas, but there are many more formulas out there. I might show you today. Actually, they are called the SU-VAT formulas. But you do need to know, first of all, the difference between scalars and vectors. So when you study physics, the very first thing that you need to learn is the variables. Because if you don't know the definitions of the variables and what they mean, it will become very difficult to do well in physics. Now, let's start with another fundamental step in physics. This other fundamental step is about learning the laws of motion. The first law, as I said, the 3 laws of motion have been examined by VCA, and sadly people haven't done as well as VCA expected them to do. Usually in past exams, actually, it very often happens that students don't do that well. They actually do very poorly. I would say about 30% of them get good marks, but the other, they do not get good marks. They don't get the marks at all. So it's very much a bivariate distribution of marks where it is very much a bivariate distribution of marks where some students get the marks, but the rest don't. So it is a good idea to concentrate. So let's start with the first law. The first law states that an object will remain at rest or travel with a constant velocity if the net force acting on the object is 0. Well, what does that mean? The key word here is net force. So net force, it's the sum of all forces. So it's the resultant force, net force, the resultant force. So if you add up everything, what is the resultant force? If the net force is equal to 0, it means that how can the net force equal to 0 to begin with? F net equal to 0. Where there are 2 ways. 1, there's no forces acting. 2, right, F net equals 0 if force 1 plus force 2 equals 0, right? They cancel each other out. So when the net F net is equal to 0, it means that this object is not accelerating, because we know that force, one of the basic formulas in physics, is m multiplied by a. So if the net force is 0, it means that this object, first of all, there are 2 options, might be at rest, right? You have like the phone sitting on your table, the phone standing on your table, just laying there. It's not moving, it's not doing anything. The net force on that object is equal to 0 in the horizontal plane, right? And in the vertical plane as well. So your object will stay at rest. That's what the first law of physics says. On the other hand, though, let's say a car, for example, if the thrust force of the car equals the friction force and the air resistance, then the car, if it's already traveling at a particular speed, it will keep traveling at that speed. Does that make any sense? If you shoot a ball in the air, even though the net force is equal to 0, just like in the car, right? If the net force is equal to 0, if there was no air resistance, if you shoot a ball, for example, in space, it will keep traveling at that velocity because there's no other force that will prevent it from deviating from that projectile, right? Same thing with SpaceX when they send spaceships in space, right? Some things they have to think about is, hey, if we're throwing stuff up there and it's a vacuum, right? If it's really a vacuum, I'm not a space expert, but if it's really a vacuum and they're throwing stuff there, well, damn, right? You don't need thrust force for your spaceship after you leave orbit. Can you see how the basic principles of physics apply? You only need thrust force from the spaceship to exit the Earth's orbit. You do not need thrust force once you're in space, right? There is no force, so the object will keep traveling. So even if you don't have fuel anymore in your spaceship, the object will keep traveling at that particular speed. Does that make any sense? So the object will keep moving at a constant velocity if the net force is equal to 0, because net force equal to 0 means, as I said, ma equals 0, and by virtue acceleration is equal to 0, which means change in velocity over change in time equals to 0, which means change in velocity is equal to 0. So for net force to equal 0, it means mass multiplied by acceleration must equal 0, which means acceleration must equal 0, which means change in velocity doesn't exist. Because obviously, mass cannot equal 0, and time cannot equal 0. So again, net force equal to 0 means the only way that can happen is if the change in velocity is equal to 0, because again, F net is equal to m change in velocity over change in time, right? So how can F net equal 0? Well, easy. Time can't be 0, mass can't be 0, but velocity can change in velocity can be 0, and velocity itself can be 0. So there's only two options. This can equal to 0 in only two scenarios: when the object is at rest, or when the interaction of the forces cancels out when an object is already moving. And if it's already moving, it will keep moving if nothing else applies on it. Now, let's look at, I think I overcomplicated it a bit. Now let's look at the second law of motion. The acceleration of an object is directly proportional to the force applied and inversely proportional to the mass of the object. So what it's trying to say is if you rearrange acceleration to be equal to force divided by mass, what will happen is you can see that for the same amount of force, if you increase mass, you will decrease acceleration, and that makes sense, right? If you keep, the only way to increase force basically is to increase acceleration or to increase mass. But to increase acceleration of an object, you must decrease its mass for the same amount of force. So if an object is traveling at that particular velocity, at that particular acceleration, in order to increase it for the same amount of force, so if there is no more thrust force, that you can apply, well, you need to decrease its mass, right? So let's say you're shooting a bullet, right? If you have a gun and you're in Ukraine right now, right? A lighter bullet can travel much faster, right? For the same amount of thrust force from the gunpowder explosion, or whatever they use nowadays. I'm not sure if they use gunpowder. They must be. I'm not sure. Yeah. Now back to the spaceship, right? If there's only so much thrust force that you can get on the spaceship, only so much fuel, right? You can only have only so much thrust force. What you can do to increase acceleration is you can decrease mass. How about the third law? The third law is the most complicated out of all. If object A exerts a force on object B will exert an equal and opposite force on object A. Note that these forces act on different objects. What does this mean? Well, if we take the example of block standing on the surface, right? If we take the example of a block standing on the surface of Earth, there is a weight force acting on the block by the Earth, right? Weight force on block by Earth. And then there is also a normal force going up. Now, most people would say that action-reaction force pairs are the weight force and the normal force, but that is actually wrong. Why is that? Why is that the case? Well, let's look at what action-reaction force pairs are. Let's look at what qualifies as an action-reaction force pair. First, they must be equal in magnitude. Second, they must be traveling in opposite directions. Right? And third, they must be applying on different objects. They must be, okay, I'm gonna say of the same type, but different objects / same type. For example, the reaction force to what you're seeing here is not the normal force. The reaction force to the weight force is not the normal force. It's actually it's actually the weight force that the block applies on the Earth. So the weight force that is applied on Earth by block P. So the reaction force to the action force of the weight force applied on the block by the Earth is the weight force that is applied on the Earth by block P. I know it is not as intuitive, But that is actually how it works. You can say the same thing about you sitting on a chair or a book standing on a table. Anything, right? For example, what's the reaction force to the normal force that the Earth applies on the block? Easy. It's the normal force that the block applies on the Earth. So this is the most misunderstood concept in physics. In fact, I strongly believe that all of Newton's three laws of motion were very much misunderstood.